Hello friends, welcome to the video lecture series on machine learning. So we have started our last lecture discussion on how we can visualize this machine learning data with the help of this MatplotLib and a pandas library in a Python. So we have seen about how we can visualize this individual attribute with respect to this histogram or with respect to this density plot. Today we are in this lecture we are going to see about how one can display plot with the box and whisker plots or a correlation plot between the two different attributes. This box and whisker plot, let's start try to understand this box. And so in a last two plotting functionality, we have seen that it is trying to tell us that for each particular attribute how many record lies in one particular range, or what is the density associated with that particular range or for that particular value of particular attribute. But what this boxer and whisk plot is like, for each and every plot it is trying to put that in a sorting order for each and every attribute, and it is trying to tell us what is the median or the middle value for that particular attribute, and it will draw the plot or a box, what is called a box and a whisker plots. It will try to draw that box which indicates that around this box or inside that box almost 25 percentile to 75 percentile of all datas lie. So it will try to tell us that between which range almost 25%, almost 50% of datas are aligned. So let's try to plot it and understand how it goes. Okay, so we have earlier also created the same function like data.plot. We are going to use almost same function, so I am just copy pasting it. So instead of density we are going to use this box, and share y also we will make it false in this case. Okay, okay, it has generated this graph for us. So if you see this box and whisker plot, let's try to understand with the age only. So this is the age attribute. So what this indicate that this red line indicates that that is the middle value of the age. So if you put all records which is available in our database with respect to age, if you sorted all those records, then the middle value is lying somewhere around the 30, and almost 25 to 30 percentile of people lies inside this box. So it is somewhere around 25 to somewhere around 40 45 some 43 somewhere around. So all those people which is the major population in terms of statistics that lies between this range. So that range is indicated by this blue square or rectangle blocks, and this red line indicates that what is the middle value with respect to that particular attribute. So that is for the box and whisker plot. Now we are going to see about this correlation matrix or a correlation plot. Now we have seen about the three different plotting: histogram, density, and a box and whisker plot. But there is a one thing common about all these three one, and which is going to become a different in a correlation plotting or correlation matrix functionality. First of all, in earlier all three plotting functionality, all plotting was done with respect to individual attribute. It is not trying to make a correlation or a dependency between one attribute on another attribute or even on another attribute. Every attribute it is trying to display individually. It has a no relation with the other attribute. But this correlation matrix is trying to give us the relation between each and every attribute. So if you have a suppose n attribute, it is trying to give us the relation between all remaining n minus 1 attribute, how it is related to one particular attribute, how one attribute is increased, then another attribute also increase. So kind of positive correlation whether exists or not, or it has a, if some one attribute is increased and another attribute is will decrease, then kind of negative correlation exists or not. So let's try to plot and try to understand this same thing on the top of this Indian diabetes patients database available. So let's first of all generate this correlation matrix. Correlation is equal to, so in on the top of data we have a core function which will create the correlation between individual attribute, and it will generate the matrix for us that how much one attribute is related to another attribute, or whether one attribute is independent of another attribute. Okay, now for the plotting functionality I have already one small routine written, because ultimately we are trying to display this correlation variable in a scatter plot manner. So this correlation is same as this one. Okay, let's try to plot it. Okay, it has given some error. I think we need to import this numpy library. Okay, still issue. Okay, I haven't copied this part. Oh, let me copy the full one, and the correlation is not defined. Okay, it has generated. Okay, this is what the correlation graph is. Now in all earlier case for individual attribute we are showing one different graph, it has no relation with the other attribute, but in this case it has generated the plot like I'm not trying to explain this routine. This is a very simple, it is trying to display that one particular attribute is how much related to any other attribute. So it is trying to display this correlation matrix only. So every correlation has been indicated by this red figure and a blue figure. So red indicates very highly correlated, and blue is -1, which is completely negatively correlated. So let's try to understand with individual attributes. So in a x-axis only, in a y-axis only, all those 9 attribute has been plotted. So if you see this diagonal line, all are the red value, which indicates that this prag is highly correlated with another prags which is the same. So any two object which is exactly similar is anyhow completely correlated. So these diagonal values are anyhow not any useful or a completely meaningless information. The important things lies the remaining value. Now whatever values are lies in this triangle, this is exactly like a shadow of this one. So if you just transpose this matrix also, you will get almost similar value, because let's try to understand with let's see prag with the age. So one attribute is the prag and one is the age. Now if you see this prag and age, it is somewhere around orange color, so it may lie somewhere here. So correlation somewhere exists around 0.6. Now if you see this prag and age here also, so this age and this part is almost similar, and so whether you compare with prag with age or age with the prag, the correlation always remains the same. That's why this indicates almost similar color. This blue kind of color indicates that there is a very small correlation, or highly going towards almost negatively correlated. So screen and a prag has no very much related with each other. But if you see reddish part somewhere, so this orange part, this plus with class is highly correlated. So that is how we can visualize this correlation matrix with the help of this matplotlib in a pandas library. So that's it for this lecture, friends. I hope you enjoy listening to this video. I'll be coming up with more and more machine learning and a pandas related video in my upcoming session. So if you haven't subscribed my channel, please do subscribe my channel. I really need your support, friends. Without your support, I won't be able to continue in maybe in the future, but I will try to continue. Okay, so please comment if you haven't understood anything, and if you haven't subscribed my channel, please do subscribe it.